I'm going to start recording now. I'll start it right on time. I'll make my introduction pretty quick. So
yeah, I've got a few SQL skills slides, the usual kind of marketing stuff.
I'll kind of let you do most of that then. Okay, here goes.
The broadcast is now starting. All attendees are in listen-only mode.
Good morning. Welcome to the second DBA Fundamentals virtual chapter meeting for March. Today's presentation is entitled Building the Right Backup Strategy. Today we have Paul Randall presenting this presentation. I'll be turning things over to Paul in a few minutes, but I want to bring a few things to your attention first. First, I'd like to thank the Professional Association of SQL Server for supporting our chapter. The management at PASS truly work tirelessly to bring free training all over the world, and they do a great job of it. My name is Steve Cantrell, and I'm DBA Fundamentals Chapter Vice President. Next month, we'll have, on April the 7th, we'll have Wayne Chavez. He'll be doing the presentation, Getting Started with Azure Database. Everybody needs to start looking at the cloud and at least familiarizing with yourself with it if you haven't already. We are recording this session, and it will be available in our archive section within a week, usually sooner than that, but just to give myself a little time. Okay, it's all the housekeeping I can think of, so let's get started. As I said, we've got Paul Randall presenting Building the Right Backup Strategy. I'm going to turn it over to Paul right now. He's got a few slides about his company.
Thanks, Steve. Good morning, everybody. And Steve, thank you again for letting me present to everyone on building the right backup strategy. So just to add to what Steve was saying about the recording, I'll also send Steve a PDF of the slide deck and also a zip file of the demos that I'm going to do. So those will be up there on the PASS website as well. So you'll be able to get all that material. So a couple of quick slides about SQL skills. There's a bunch of us who work for SQL skills. You probably recognize some of those names there. Glenn and Kimberly have already presented for the DBA Fundamentals VC this year. We do training, we do consulting, blah, 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 marketing stuff. There's just an idea of some of the stuff that we present about. We have a whole bunch of different classes coming up this year in Chicago, Bellevue, and if you're international, then London and Dublin. We've already done Sydney and Australia earlier on. And there's a list of some of the stuff that we teach in one of our performance tuning classes. If you're interested in any of our training, instructor-led in-depth training, go to the link there at the bottom of the screen, sqlskills.com/training. So about me, my name's Paul Randall. I used to work for the SQL team for about 9 years or so. I wrote DBCC CheckDB, a bunch of the storage engine code, blah, 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 blah. Okay, so interesting stuff. So my email address there, paul@sqlskills.com. After this session, if you have any questions about the stuff that we're talking about in this session, if you're watching this offline, for instance, and you have a question, by all means send me a question in email and I will answer it. Just make sure you say I'm watching the past VC presentation so that it bubbles up, because I get an awful lot of questions every day. I want to make sure that I answer yours. And then our blogs, there's all of us at SQL Skills, we blog an awful lot, lots of free information, no marketing or advertising or anything like that, just lots of free stuff. And then Twitter as well. So a whole bunch of us are on Twitter. There's a very vibrant SQL Server community on Twitter. And I'm on Twitter. All the people at SQL Skills are on Twitter. Steve Cantrell's on Twitter. If you have a question and you want some free help, go onto Twitter and add #SQLHelp, all one word, onto your tweet. And a whole bunch of people like me and other MVPs and consultants look at that and you'll get some free help, which is pretty cool. And then the last thing, we at SQL Skills, we have a bunch of online training as well through a company called Pluralsighto. And if you're interested, I can give you a completely free code to get 30 days of access to all of our 125 hours now of content, recorded content up on Pluralsighto. You don't have to add a credit card or anything like that. It's just completely free. Just send me an email with that subject line there and you'll get a code. Okay, so there's an awful lot of interesting courses on there. I don't specifically have a backup and restore course on there yet. That'll be coming later on this year. But and this is like a 200-level course that we're going to be doing today. But I do have a couple of courses on corruption and corruption recovery techniques where I cover some more in-depth uses of backups and restores that we're going to be covering today. So there's a couple of examples there. So on with the show. How to plan a backup strategy. That's what you're all interested in. And my simple answer is don't do that. Okay? Don't ever plan a backup strategy. If you start by planning a backup strategy, you're going to do something wrong. What you need to do is plan a restore strategy. Okay? You want to figure out what the restore options you want to do, and then that's going to tell you what backups you need to have to be able to do those restores. Here's an example. So here's a question. A story from my past. Back when I was on the SQL team, I went on a program. This is back in like 2004. I went on a program called Frontline, and it was a Microsoft program getting senior developers out onto the front line, working with product support to get an idea of what goes on out in the field. And I was over in Charlotte, North Carolina, and I was sitting there in the product support group, and I was helping on their one of their call-in email queues, phone queues called the server down queue. So called because people would call in and say, you know, help, my server is down. And what happened this day, this was on a Tuesday, I remember, and a small bank from the Midwest of America called in and said, hey, we've got all this corruption, can you help us? And we said, what backups do you have? And they said, well, we don't really want to go there yet. And we thought that was kind of weird. But we said, okay. So we helped them take a copy of their database. We ran repair on the copy of the database, and it deleted a whole bunch of stuff. And they had all kinds of corruptions. And they said, well, we can't accept that. We can't have any data loss. And we said, okay, what backups do you have? And this was in April 2004. And they said, well, we're in the full recovery mode. We did a full backup and back in January. We've been doing log backups every half an hour since then. So we very quickly pressed the mute button on the phone, and we all started to giggle, thinking, my goodness, they've got so many backups. There's no way this is ever going to work. And so we kind of composed ourselves and pressed the mute button again and said, wow, my goodness, that's amazing. So you've got about 5,000 backups then. And they said, actually, it's a little bit worse than that because all the backups are actually on tape. So we very quickly pressed the mute button, we giggled again, and we got back online with them and said, wow, that's pretty amazing. It'll be interesting to see whether this actually works or not. So we put together a restore script, and we worked with them, and lo and behold, miracle of miracles, all of their backups actually restored. Okay? So they got back up running without any data loss at all. However, it took 3 days to do it. Okay? So by Friday, they called it on Tuesday, by Friday they'd come back online, and they had no data loss. Now, in the interim, the entire bank was offline. So nobody could accept payments, they couldn't get any money out of ATMs, nothing at all, absolutely nothing. Now, think about this. If your bank has some kind of IT disaster and your bank is down for, say, half a day and you can't do stuff, what are you going to do? Probably nothing. You might be a bit annoyed, but you're not going to go out and change your bank because changing your bank is a real pain. But if your bank is down for 3 whole days, okay, and you can't do anything at all, then you're not going to trust them and you're going to change banks. And actually they went out of business because of this incident. So what turned out to be the issue was somebody in their company had set up this backup strategy where they said, well, we've done a full backup, we're doing regular log backups, and we're in the full recovery model, so we can recover if there's a disaster. But they had never actually tried it. Excuse me, they'd never actually tried doing a restore strategy. So when it came to actually doing the restore for real, they found that they didn't have the backups that they needed to be able to do the restore that they wanted to do. And the restore they wanted to do was restore within half a day or a day or so. Okay? And so their mistake was they planned a backup strategy without thinking at all about what restores they wanted to be able to do. And that's why I say to you, don't ever plan a backup strategy. Plan a restore strategy. What do you need to be able to restore? How quickly do you need to be able to do it? And that's going to dictate what backups you have. And then once you have your backup strategy, dictated by your restore plan or your restore strategy, you need to test it to make sure it's actually going to work. That backup strategy that you're going to have is generally going to turn out to be using the full recovery model, using a full backup, transactional log backups, and probably differential backups as well. Right. So what are we going to cover in this session? We're going to cover a little bit about planning your strategy. We'll talk about some of the simple types of backups. We'll talk about some simple restores you can do, and then we'll look at a few different sample backup strategies. Now, obviously, we only have an hour or so to go through this stuff, so we're not going to be able to cover every single type of backup, all the different twists around file group backups and using partitioning and laying out all kinds of different stuff. Okay, this is really just a simple, this is the DBA fundamentals chapter, obviously, so this is going to be a simple session about backups and what they are and how to use them. And I'm going to give you a whole bunch of links where you can go and investigate in kind of background resources some of the more advanced topics around backups. And we'll stop every so often, and Steve will read out any questions that have come in through the GoToWebinar interface, and I'll answer the questions to the best of my ability. So planning the strategy. So when you're figuring out what your backup and restore strategy is, that's integral to designing the overall system, your HADR strategy as well. Now, if you're just getting into being a DBA, you may not be the one that's been tasked with designing an HADR strategy. Okay? But the kind of requirements that you're going to need to be able to figure out what your backup and restore strategy is also play into HADR planning. Okay? So as it says there on the second bullet point, even if you have the most sophisticated redundancy setup, you might have database mirroring or availability groups and multiple data centers. If absolutely everything gets destroyed, the only way you can recover is using backups. Okay? So you need to make sure you have backups, and you need to make sure you have multiple copies of backups. Because if the only copy of your backups is on the same RAID array as the data files themselves, you're inviting absolute disaster and complete data loss. You have to have a separate copy of your backups stored somewhere where it's unlikely they're also going to be destroyed if some kind of disaster happens. Okay? So as you're gathering up your requirements, we're going to look at some of the very simple requirements that are going to feed into your backup and restore strategy process, if you will. You've also got to think about how much storage space is required for backups as well. Because depending on the size of your database and how long you need to keep backups around, that could add up to quite a lot of storage space. For instance, if you're in the financial industry in the US, you've got to keep your backups around for 7 years. Okay? So that also has to be factored in as well. You don't want to be running out of space for your backups. So figuring out what restores you want to be able to do has to take into account at least the following three things. What it is that you're trying to protect, your data loss service level agreement, and your downtime service level agreement. So the downtime SLA, service level agreement, or SLAs, is how much downtime you're allowed to have by the business until you can be back up and running. And this is often known as the RTO, the recovery time objective. And the simple way that people discuss this is in terms of number of nines. Okay, so for instance, 5 nines. You've probably heard 3 nines, 4 nines, 5 nines. 5 nines, if you're talking about 24/7, 5 nines means you can have about 5 minutes of downtime per year. Right? So this is 5 minutes of however you're tracking downtime. And that could be the amount of time that the application is unable to connect to SQL Server. So if you're not able to, if you're trying to do 5 nines downtime, that means that you can almost not even just reboot your server once. Right? Because, for instance, power on self-test for a typical server might take 1 to 2 minutes. And then SQL Server has to run all of its crash recovery. And then the application has to be able to connect to SQL Server. So 5 nines is extremely hard to achieve, if you're talking about a 24/7 operation. Right. 4 nines at 52 minutes a year, that's a little bit easier. Many people go for like 3 nines. Right? So that's like almost 9 hours of downtime that you're allowed to have per year. Now you also have to figure out what does uptime and downtime mean to you? Right? Is it 24/7? Okay, which means that the more nines you want, it's very, very hard. Or is it that number of nines over 9 a.m. to 5 p.m.? That's an awful lot easier because that means you've got a lot of time available for database maintenance, for instance, for running index rebuilds, for doing patching and stuff like that, for testing failovers and things. Okay. You as a technologist, you're probably going to be asked for 0 downtime. Okay. And 0 downtime is almost impossible. Okay. You're going to have to push back and say what it is that you're actually able to do. And that could be something like 3 nines. Okay. Now, if you're wanting to have the lowest possible recovery time objective from restoring from backups, you're probably not going to be able to just use log backups. You're going to have to use differential backups as well. And we'll talk about what differential backups are as we go through later on in this deck. So then data loss SLA, or recovery point objective, how much data you're allowed to lose. Right? Now, 0 data loss is much more achievable than 5 nines uptime. Okay? 0 data loss you can do just using backups. Right? It's a lot easier to do 0 data loss if you've got something like synchronous database mirroring or some kind of synchronous availability group replica. Okay? But you can do it with backups as well. Now, if you're looking at doing 0 data loss using just backups, then you are going to have to be taking log backups. Right? Because the only way to restore right up to the point of a crash is using a log backup. And we're going to talk about log backups as we go along as well. So these SLAs are extremely important, okay, the RTO and the RPO, because the RTO, the recovery time objective, says how long you've got to do all of the following. Figure out where your backups are. And you might have some kind of run book or disaster recovery guide that's going to help you or tell you where the backups are or where the scripts are that allow you to find what backups you have. And then, so finding all the necessary backups, figuring out what the restore sequence is that you're going to do, performing all the necessary restores, make sure that everything's working again, right? Which could be you've got some kind of application check routine that makes sure that all the data's there, right? And then the application connects in again. So all those things are covered by RTO, not just how long you have to restore a backup. Okay? And it could be that your disaster recovery book or run book or guidebook or whatever you want to call it doesn't talk about backups at all initially. If you have a problem, it might just say, okay, fail over, right? And then go back and fix the problem on the other site using backups. Right? It all depends on what your particular scenario is. And RPO defines how close you have to get to the current point, how much data you're allowed to lose. And again, you're going to be using log backups to do that. Or okay, you're going to have some kind of synchronous database mirroring or synchronous availability group, or maybe synchronous, some kind of I/O subsystem replication. Okay. Now, with RTO and RPO being what they are, and you're likely to be asked for as little as possible, right, for both of these, you're going to have some kind of HA solution like the standard replication, database mirroring, availability groups, or whatever, and have backups as well. You can't have just one or the other, right? Because if you're relying just on backups, it's likely that you're not going to be able to get the lowest RTO and RPO. And if you're relying just on one of the HA solutions, then what happens if that goes wrong? What happens if you lose the other data center? And what happens if the network goes down and you can't fail over? You have to have backups as well. So you can't get away from having a good set of backups. So what is it you're protecting? What you're protecting, or what has to be able to be restored, might dictate how you lay out the database in terms of file groups, for instance. If you're protecting the entire database, right, that's probably the simplest thing, but then you're going to have a full backup, but then you have to be talking about log backups as well. So what's your transaction log generation rate? How big are your log backups going to be? How often do you want to take log backups? You're going to be doing every half an hour, every 15 minutes, every 5 minutes, every 1 minute, right? If you're just looking at a single critical table in a very large database, right, you can't do a single table restore from SQL Server backups. You can from third-party backup software, but not from SQL Server backups. So maybe you have to isolate that single table onto its own file group so that you can do targeted file group restores. Okay? There's all kinds of different options there. Okay? So depending on what it is you're protecting, that might play into what your backup strategy is, or what backups you need to be able to have to facilitate certain kinds of restores. So we're going to just pretend, though, that you're doing what most people do, which is a full database. So you're just talking about a database level backup and then log backups and potentially differential backups as well. Okay. Hey, Steve, any questions so far?
None so far. Hold on, somebody just came in. Is it beneficial to have multiple differentials daily?
So why don't let's hold that question until we talk about differential backups, and we'll talk about what it is that they actually provide you, because then it'll become more clear what the benefit of differential backups are and why you might want to have multiple of them. And if it's not clear, ask the question again once I've talked about differential backups.
That's it for right now.
Okay. So the different types of backups, right? A full backup, a differential backup, and a transaction log backup. Right? So a full backup, when somebody says a full backup, they're generally meaning a full database backup. Okay? Now, a full backup just means that you're backing up the entire contents of something. And you can do full backups of a database, a file group, or a file. File group and file level backups are more advanced. They're not as commonly used, nowhere near as commonly used as just regular full database backup. So from now on, for the rest of this presentation, when I say full backup, I'm talking about a full database level backup. And you can do a full backup in all recovery modes, all recovery models. So that's full, bulk, logged, and simple. Okay? And what a full backup does in each of those recovery modes is exactly the same. A differential backup, you can again do it for different granularities of the data portion of the database, right? And again, you can do those in all recovery modes. We're going to talk about differential backups a bit later on, and I'll be talking about differential database backups. Right? And then transactional log backups we'll also talk about, and they are just for the entire database. And you can't do transactional log backups in the simple recovery mode. So a full database backup, that gives you a single starting point for any potential restore sequence, okay, or any recovery strategy. And it is a complete image of all the allocated pages in the database. That's very important because you might have, for instance, let's say you've got a 300 gig data file, and that's your database. And you do a full database backup, and it's only 100 gig in size. Right? The full database backup doesn't copy the unused portion of the database. It's only those portions of the database that have data in them that are put into the full backup. Right? You don't have to take any downtime while you're running a full backup. In fact, with all backups, you don't have to take any downtime. Okay? You can do all backups online. Right? So you're not just using usually a full backup, because a full backup only gives you a single point in time that you can restore to. You're generally going to be using a full backup with some other kinds of backups, at least log backups, so that you can do what's called rolling forward or restoring more backups to bring the database to a more recent point in time, and that process is called rolling forward. So the image of the database that you get, there's a lot of confusion about this. It's backup completion. Okay, and I've got a picture on the next slide that's going to show you the point that you get. It's not the start of the backup. Right? So the backup starts here. So this is us saying do our backup. What's going to happen? The first thing that's going to happen is the system's going to do a checkpoint, and that's going to flush out all changed data file pages so that what's in the data file is as up to date as possible. And then what's going to happen is the system's going to back up all of the data file pages in the database. Right? Now at that point there, where we get to here, right, the backup's not done yet, but it's finished backing up all of the data file pages. When you do a restore of this backup, the point in time that you get is here. This is the point that you get when you do the restore of a full backup. Okay? It is not back here. It's over here. So it's actually at the end of the data reading portion of the backup. That's the point in time you get when you restore a full backup. Now, the data pages are read, but they could be transactionally inconsistent. Okay? There could have been a transaction that happened at the same time that we're backing up these set of pages that changed a table and some of its non-clustered indexes. Now, to make sure that when this backup is restored, the data is consistent between all the different portions of a table, a full backup also has to back up some transaction log. Okay? And a differential backup also does this as well. So what's going to happen is at the time that we did our checkpoint back here at the start of the backup, okay, the system makes a note of this point in the transaction log. Right? And then once the data reading portion of the backup is finished, it goes back and it also backs up all of this transaction log that occurred from the start of the backup all the way to the end of the data reading portion of the backup. In fact, it goes back a little bit further, and I've got this on a slide coming up. It goes back to the start of the oldest active transaction that was running as of this point of time, which could be here. And if you have transactional replication set up and you haven't had replication pick up transactions for a while, there might be the oldest unreplicated transaction, which could be even further back in time. Right? And all that log has to be backed up as well. And that is so that when you do the restore, if the only thing that you restore is your full backup, right, it has to be able to use all this transaction log to essentially run crash recovery on that restored copy of the database to make sure that all of the transactions are reconciled correctly so that you have a transactionally consistent view of this database once you restore that backup. So that's what a full backup does. Okay? Now, at the same time that full backups are running, you can also do log backups. In SQL Server 2000 and before, you couldn't. Okay, the log backup would be blocked until the full backup completed. But from 2005 onwards, you can do concurrent log backups. Okay? However, there's an interesting kind of catch to that, which is if you're doing concurrent log backups, the log backups will succeed. They will be able to back up portions of the log. However, log clearing will not be done. So the system that goes in and marks portions of the log as available for reuse cannot be done until the data backup finishes. So at the end of the data backup, any log clearing that would have been done by concurrent log backups happens. It's called deferred log clearing. Okay. So that's how a full backup works. So there is just some of the stuff that I've already said. It does a checkpoint to make sure that all of the updated pages are on disk. It reads all the data, and then it goes back and reads a whole bunch of transaction log to make sure that the backup contains enough information to be able to run crash recovery properly on that restored copy of the database. Any questions about full backups and how they work?
Yes. Okay, I think you answered the question, but I'll read it anyway. Just for my clarification, a full backup does not truncate the transaction log. Is that correct? You must run a log backup to do that, not talking about shrinking.
Correct. So clearing or truncating the log is only ever done by a log backup if you're in the full or bulk log recovery models. Now the situation that I just discussed where you're doing concurrent log backups while a long data backup is running, okay, at the end of the data backup, the backup system is told by the log management system, hey, there was some deferred log clearing. Can you go ahead and do that, please? So at the end of the data backup, you might see the log clear, but it's not the data backup that's doing it. It's deferred log clearing from concurrent log backups. And it's very confusing because it makes you think that the data backup is actually clearing the log, but it's not. It's only because there's been deferred log clearing from concurrent log backups.
Okay, what happens when backing up to multiple files during the full backup?
So when you're backing up to multiple files, so you're doing what's called a striped backup. There's going to be multiple backup devices, and these are the backup files. And what happens is the backup system will pull some data from the data file, and then it's going to essentially round robin through the various backup files that you're backing up to. Right, so what's called a backup buffer will get filled up, and it'll be written out to whichever is the next backup file to be written to. And so you might think, well, how on earth does this work? How does the backup system keep track of which portions of the data file are in which backup files and so on? So the backup file itself, or the backup files, have an internal data structure, and it's based on the Microsoft tape format, which is, if you dig around, you'll be able to find a little bit of information about it, but it's really an undocumented structural format. And so each of the backup files has a series of what are called backup streams inside it. The backup stream has some metadata information that says whether the information in this backup stream is from a data file, from a log file, and where it's from inside that data file or log file. So the various backup files can have, various disparate portions of data and log inside them, but the structure of the backup files, there's enough there for the restore system to be able to piece everything together and put stuff down into the right order. Hopefully that answers the question. Probably over-answers it.
Okay, can compress backup, of course. If yes, what are the precautions that need to be taken?
Any extra precautions that need to be taken with compressed backups? No. So I believe I mentioned backup compression very quickly, just as a way to be able to obviously reduce the size of some of your backups, but also to speed up the backup and restore process. Because any time that you're using compression, if you're using backup compression and you're getting some kind of decent compression ratio, say, I don't know, 20% or higher, then that's going to make your backups go faster. Because backup is basically read, copy, and then write. Right? So if you can reduce the amount of data that's being copied and written, then your backup's going to run faster. And also, the restore is basically read, copy, and write, going the other way. And if you can reduce the amount of data that's being read from the backup files, that's going to make your restore faster as well. So compression is generally something that can be good to use, but there's no extra precautions that you need to take to use backup compression. I guess the only thing I would say is you can only create compressed backups on 2008 on Enterprise Edition and on 2008 R2 and onwards on Standard Edition as well. So all editions, though, can restore compressed backups. So you don't have to worry if, for instance, you're still on SQL Server 2008 and you're creating your compressed backups in Enterprise Edition, you don't have to worry that you're only able to restore, for instance, on a cheaper Standard Edition server. That's still going to be able to decompress your backups.
Okay, this is a follow-up to that. Can you compress backups if your data is encrypted at rest?
If you have transparent data encryption enabled, then you're not going to be able to make use of backup compression. Now, let me clarify. You can specify backup compression, but it's not going to do anything, because what backup does is a straight copy of what's in the data files. It doesn't go through the buffer pool at all. Backups open direct channel straight to the data files themselves and read the data directly. So the data, if it's encrypted by transparent data encryption, is not able to be decrypted, because it's the buffer pool that does the encryption and decryption for TDE. So if you're using transparent data encryption, your data file is basically a string of small random integers, and a string of small random integers is not going to compress. So if you have TDE turned on and you try backup compression, you're going to see that basically you get a 0% compression ratio. So I would say that for any databases where you're using TDE, you don't use backup compression. So if you've turned on backup compression at the instance level, which many people do, then for those databases that have transparent data encryption turned on, I would specify with no compression on the individual backup statements.
Okay, this one is related to backups with replication. Should you back up the subscriber before the publisher or concurrently? Or does it matter?
It doesn't matter what order you do the publisher and the subscriber. What you want to make sure is that you're backing up the distribution database as well. So the publication database and the distribution database. The distribution database, see, many people, when they're thinking about doing backups, they forget to do the system databases as well, master model and MSDB. And they're all extremely important. And you should also make sure that you count distribution as a system database, because that's going to be what's going to allow you to make sure that you can recover replication in all kinds of scenarios. And replication as a whole, I mean, we could talk for days about replication and all the weird things that replication does. But no, it doesn't. I can't think of a reason why you would want to have any strict imposed ordering on whether you back up your pub before your sub or vice versa.
Okay, this was, should you run a backup before or after re-indexing?
No reason to run a backup before or after doing a reindex. I mean, you're running backups. Remember, the reason that you're taking backups is to be able to do the restores you want to be able to do. Okay. Now, there's other reasons to do backups, like you're initializing a log shipping secondary, you're initializing a database mirror, or you're taking a copy of the database for developers. But there's no reason that you have to take a backup because you're doing some large operation like index rebuilds or a big ETL or something, unless you're concerned that something's going to go wrong. Now, you shouldn't be concerned that something's going to go wrong with index rebuilds. Okay? You might want to do a backup before you do some massive data load if something goes wrong with the data load and your business needs are that you have to be able to roll that back. Okay, that could be difficult to do. Okay, so you might want to have a set of backups to allow you to do that. But I wouldn't worry and specifically do a backup just before you're doing index rebuilds. I don't know of anybody that has that requirement built in.
Okay. The next questioner prefaces it saying, this is a big question, so I'm just asking for resources. Do you have a good strategy for backup restore using availability groups? I know there's a lot of gotchas, so I want to start learning about a solid plan for it. Thank you.
I don't personally have a resource because I'm not our availability group expert. But the thing that I'll say about AGs is there's complication around how you offload. You can offload your backups from the primary replica to a secondary replica, and there's some complication around MSDB in the backup history tables and log backups and differential backups and so on. I'm trying to think about who would be a good resource or where there would be a resource. I can't think of anyone in particular that I've read anywhere, but my guess would be if you, in all seriousness, if you just Google availability group backups, you'll find a bunch of resources, probably some Microsoft stuff. You might find stuff that Jonathan has done. You might find stuff from other consultants. I know Brent Ozar does a bunch of stuff with availability groups. They've probably got something up there about backups. We've probably got something up about backups as well. I just don't know where it is off the top of my head. If you can't find anything, send me an email and I'll see what I can find for you.
Okay. I have a SQL Server with 6 databases all in simple mode. I've been asked to change these databases to full and start taking transaction log backups. How do I estimate disk space needed for the increased size of the log file and the new transaction log backups? I don't want to run out of space and cause an outage.
Interesting. So what you're going to have to do is figure out what your transaction log generation rate is. Okay? And generally the way that I figure out what the transaction log generation rate is I look and see how big the log backups are. So there's a kind of circular catch-22 problem there based on what you're asking. So to be honest, what I would do is I would just go ahead and do the switch to the full recovery model, and I would monitor it closely for the first day or so to see whether the log, well, and I would put in place something like hourly log backups. Okay, and if you see the transaction log is growing, and you see the log is growing because there hasn't been a log backup, right? And you can see that by going to sys.databases and looking at the log underscore reuse underscore wait underscore desk column. If you see it saying the log underscore backup, that says the log's growing because you haven't done a log backup. Right? So then I would maybe change your log backup frequency to be more frequent, maybe say every half an hour, right, to get to the point where the log has reached some kind of steady state size and isn't growing. And then what you're going to do is over a period of time, whatever your kind of business life cycle is, you're going to sum up the size of your log backups, and that's going to be how much space you're going to require. Okay? There's no real simple way of doing it apart from that, okay? Unless you happen to know what all the transactions are doing, how much transaction log is generated by each of those transactions, and that's extremely hard to do. Right? So I would go the simple route, no pun intended, based on recovery models, and just switch to full and put in a log backup and just see what it does on your system and tweak as necessary.
Okay, we've got 2 more. The hidden system database, the MS SQL System Resource Database file, when and how should you back that up?
So the resource database is actually a static, you can kind of think of it as a static DLL. It never changes apart from when you're doing potentially cumulative updates or service packs. So what you should make sure you do is you have a copy, just do a file level copy of it, and you might have to do the file level copy while SQL Server is shut down, while you're doing some kind of maintenance, okay, on your server. Just make sure you have a file level copy that you can drop back into place if you have any kind of disaster. You can also get it from I believe you can get it from the install media as well. I don't remember exactly where it is, but if you go to Books Online and you search for system databases, there'll be a section on backing up system databases and a section on restoring system databases, and one of them will talk specifically about the resource database. But you can just do a file level copy of that because it's not a real database per se.
Okay. Does the SQL Server backup affect the performance of the SQL Server? As we got complaints from that team, their application was slow during this time when the backups are running. Obviously, it uses CPU.
Okay, so there's 2 parts to this. There's, are you using compression or not? So if you're using backup compression, that's going to burn a bunch of CPU. And if you're CPU bound on your server, then that could affect your system. Okay? If you're not using backup compression, then you're looking at the I/O. Right? So if your system is I/O bound and you add a bunch of extra read I/O onto the system, then it's possible that that could slow things down. Okay? Now, that is not a reason to not do backups. Okay? You want to figure out why there's an I/O bottleneck that's causing the transaction workload to be affected when you're running a backup. Okay? And that's a whole other discussion that we can have. But in general, backups don't cause blocking. Right? So the only issues you're going to have are potentially CPU if you're doing compression, very minimal CPU if you're not doing compression, and then the extra I/O that's involved.
Is there a simple way to restore backup from a higher SQL Server version to a lower SQL Server version?
No, it's not possible. You can never, ever, ever take a backup from a higher version and restore it to a lower version. It's not possible at all. Never has been. Okay. So what you're looking at is a data extraction and then insert into the lower database system. You can only ever go from a lower server to a higher server. So SQL Server is down-level compatible. It is not up-level compatible. and never has been, and probably never will be.
Can you run reindexes while a backup is running? Will it cause issues with the backup?
If you're in the bulk log recovery model, you might have an issue because you can't do bulk operations while a log backup is running. Okay, there's a bulk operation, what's called a sub-resource lock, held while a log backup is running and while a bulk operation is running, and the two are incompatible. It shouldn't cause a problem if you're using data backups, though, and in the full recovery model, it shouldn't be a problem ever. But in the bulk logs recovery model, you might have an issue around log backups and rebuilds at the same time.
Okay, what's the best way to determine your initial log size to prevent lots of VLFs?
Slightly off topic, but the best way to, there's a number of different things you can see for how big your log should be. Okay, number one, what's your biggest transaction? Your single biggest transaction has to be held within the log. So that could be a large ETL, a large update, it could be a index rebuild of a clustered index in the full recovery model. Okay. Then you've got to think of how often are you doing log backups? All the log between those two log backups has to be held in the log. Okay. If you're using replication, how often do you allow the log reader agent job to run? All that log has to be held in the log. If you're doing a full backup, what's the longest full backup that you have? Okay, so if, say you do a full backup once a week that takes 8 hours. 8 hours of transaction log has to be held inside your log. Okay, so all those different things, you can come up with some kind of wild-ass guess how big your log is going to be. Figure that out, create your log to be that size, put it in production, and monitor it. If it grows a little bit, but it still seems to be a reasonable size, and there's no formula for what reasonable is, if it seems to be a reasonable size, that's the size it should be. If your log kind of grows wildly, so maybe you've got like a 20 gig database and you've got a 150 gig log, then that doesn't seem to be a reasonable size to me. Okay, so then I would tweak how often you're doing log backups, have a look and see whether you've got some kind of runaway transaction. You know, somebody's done some wild, horrible thing that is updating every row in your database by accident. But those things that I've talked about are how you can come up with a simple estimation of that. And I believe if you look on Google, if you look for transaction log size and SQLmag.com on my old SQL Server Magazine blog, I did an article that listed all those different things that you could do to see how big your log should be.
Okay, we've still got 3 or 4 more questions, so maybe if you want to continue, do you want to keep doing the questions now, or do you want to wait until the end of the presentation?
How about I do a few more slides, and then we'll do a few more questions.
Okay, sounds good.
So for people listening in, we will get through all your questions. I don't have anything else scheduled this morning. So I'm happy to keep going for as long as you guys have questions. But for those of you that are watching and want to see the presentation, I want to make sure I get through the slides so that those of you on your lunch breaks and so on can watch, and then we'll carry on with questions. All right, thanks, Steve. So going back to full database backups, this is what your strategy is going to look like if you're only using full backups. So let's say that this is once a week. So maybe on Sunday morning, midnight, Saturday night, Sunday morning, you do a full backup. Okay, this is what your strategy is going to look like. You get one full backup once a week. Okay? So if, for instance, our database gets trashed at, let's say, 11:59 p.m., worst possible case scenario, 11:59 p.m. Saturday evening. Okay? We've lost everything since the previous full backup because we don't have any other backups to allow us to restore. We have to go back to the most recent full backup, which is the previous Saturday night, Sunday morning. So this is why people generally use log backups as well. So a log backup, it's an incremental backup. It backs up all the transaction log that's been generated since the previous log backup. Okay? Now the idea is you're taking them quite frequently, and what frequently is going to be different for all of you out there. Okay? But a typical log backup maybe every hour, every half an hour, every quarter of an hour, something like that. Okay? And they're going to be fairly small. Now the periodicity of your log backups is really going to be defined by how much data you're allowed to lose. Right? The smaller the amount of data you're allowed to lose, the more frequently you have to do your log backups. If you're doing log backups every 15 minutes, you're saying you might allow up to 15 minutes of data loss. Okay. So once the log has been backed up, SQL Server is going to try and do what's called log clearing or log truncation, where it looks and sees for all the portions of the log called VLS or virtual log files, for all the portions of the log that have been backed up now and are no longer needed for anything else, which portions can I mark as available for reuse. Okay? And that's a whole other discussion, and maybe at some point later on in the future I'll come back and do a 200 level session on transactional logs and transactional log management and how they work under the covers as well. So in the full and bulk log recovery models, you have to do log backups frequently because that is the only thing that's going to allow the log to clear. One of the most common causes of kind of out-of-control transaction logs is somebody does a full backup, right, which puts the database into the full recovery model. Even if you've switched the database to the full recovery model, it's not really there until you've done your first full backup. Once you do the first full backup, the log will grow forever unless you do transactional log backups. Okay? There's no blocking from transactional log backups. In fact, any log backups, any backups at all, don't cause blocking. There is this weird case around in the bulk log recovery model with log backups and bulk operations, right, but that's a kind of minimal case. Okay? Regular transactions are not going to be blocked by backups occurring. Now, why are you taking log backups? Well, to be able to allow a restore sequence or a restore strategy that restores the database up to the point of failure or close to the point of failure, to allow you to restore to a particular point in time. Right? Or if you're using log shipping, for instance, you have to be doing log backups as well, because log shipping is basically backup, copy, restore over and over and over. So looking at log backups in the context of the transaction log. So in our log here, okay, we have a very simple picture of a log. So we have these white lines here are the divisions between virtual log files in the log. Right? So what we've got is we've got 3 virtual log files here at the beginning of the log that have been used, right, and they're not being used for anything else, but they haven't yet been backed up. Right? We have this is called the active portion of the log. All these log records in these VLFs are required for, say, active transactions. Okay? And we've got this bit of the log at the end here that hasn't ever been used. This is a highly simplified look at the transaction log. So our first log backup is going to back up, let's say our first log backup ever is going to back up all the log that's been generated so far. So that's going to be this portion here, right? All the way up to the most recent log record. And then it's going to look at trying to clear some portion of the log. Now, there's a VLF divider here. So this VLF is still actually in use, okay, so can't be cleared. This VLF here has some log records that are still required for, let's say, an active transaction. But all of this portion back here is able to be cleared. Okay, so the log backup goes ahead and clears that portion of the transaction log. Okay, so that's our first log backup. So remember, we've written up to here so far. So now let's say that we've moved on a little bit and we've now written a few more log records. So this is where our last log backup backed up to. The next log backup will back up everything since the last log backup. So it's going to back up all of this. Okay? Like so. And then it's going to try and do log clearing again. And it's going to be able to back up, it's going to be able to clear some of these earlier VLFs. And remember, this one was backed up previously but couldn't be cleared. This one was in use previously, so of course couldn't be cleared. So then it's able to clear some more of the transaction log. And you can see basically we have this kind of sliding window of portions of log that are in use, portions of log that are being cleared out, right? So that when the transaction log reaches the physical end of the log over here, the log management system is able to look back and say, oh, this very first VLF, is that able to be reused? And if the answer is yes, then the log wraps around and doesn't have to grow. So if we hadn't been doing log backups, these earlier VLFs would not have been cleared out, they would not have been available for reuse, and so the log would have had to grow. Right? And that's exactly what this slide is saying. Right? So we had, this was our most recent log backup previously. We carried on writing. We got to here, boom, we bumped into the end of the log, and we wrapped around to here because we were able to, and then we carried on writing to here. So the next log backup is going to back up all of this transaction log to the end of the log. It's going to wrap around and then carrying on backing up transaction log to here, like so. And then it's going to clear what it's able to clear. Okay? And so on, and so on, and so on. Okay, so that is what log backups are doing under the covers. Now, if you've got a minimally logged operation, so in the bulk logged recovery model, Okay, if you've done something like an index rebuild or some kind of bulk insert, then you've got some portions of the log are only holding what's called minimally logged operations. So a minimally logged operation doesn't log, so let's say we're doing an index rebuild. A minimally logged index rebuild does not log the page being allocated, log all the inserts into the page, move on to the next page. All it does is log the page being allocated, log the next page being allocated. So it's minimally logging the operation. Now the inserts are actually happening, but they're not in the transaction log. So the next log backup after a minimally logged operation has to back up all the log, as it would usually do, but also it has to back up a bunch of pages from the data file. All of the pages from the data file that were inserted into as part of that minimally logged operation, so that the transaction log holds all the information necessary to fully reconstitute that transaction if a restore is necessary. If all the log backup did after that minimally logged operation was back up just the log file, it wouldn't have enough information to be able to reconstitute that, for instance, index rebuild. So that's a special case. So going back to our strategy, right? So if we want to make sure that in terms of data loss, if we only have full backups, we lose potentially an entire week's worth of data. If we want to change that, then we could do a log backup. And let's say we do a log backup every half an hour. Now this picture is obviously simplified. So let's say that this here is Saturday night. Right? So let's say that we get to 11:59 p.m. Saturday night and the system crashes and we have to do a restore. Now we have our full backup once a week and our log backup every half an hour. So we're going to have to restore our full backup, and then we're going to have to restore all of the log backups through the week. Okay, so 48 log backups every day, so 6 times 48, right, plus 47 log backups to get us up to like 11:30 p.m. on Saturday. That means we're not going to have anywhere near as much data loss as the full backup only strategy. However, there's an awful lot of log backups that have to be restored. Okay? So that might not be the best strategy either. Remember the case of the little bank that I told you, the story I told you earlier on, where they had over 5,000 log backups over 3 months. Okay? Not an optimal situation. They had no data loss, but their recovery time was very long. Okay? So that's where differential backups come in. What a differential backup is what has changed in the data file since the last full backup. Okay? Now, many people get confused about differential backups and think that they're incremental data backups. They're not. SQL Server does not have incremental data backups like other relational database management systems do. Right? Differential backups are everything that's changed since the last full backup. And they're very, very cool because if you think about what a differential backup is doing, it's essentially the net effect of all the log backups over the same period. And they're way, way faster to restore because all it does is it just lays down all the data file pages that have changed rather than having to go and replay all the log records and transactions that have happened from all the log backups. Okay? So what a differential backup does under the covers is after a full backup has happened, right, whenever a portion of the data file is changed, it's marked as changed in a special bitmap, 1 every 4 gigabytes. It's called a differential bitmap, okay, or the differential change map, or DCM, depending on where you look. Okay, different people call it different things. So when a differential backup runs, it goes and looks at these bitmaps, and it just backs up those portions of the data file that are marked as changed. Okay? So as you move forward in time, and more of your database gets changed, successive differential backups get bigger and bigger and bigger. Okay? And eventually you're going to do another full backup, which will zero out all those bitmaps, right? And then you'll start doing differential backups again. So a differential backup is based off one full backup only. It cannot be restored after any old full backup. It has one full backup that it can be restored from. The most recent full backup before you took your differential backup. Okay. So going back to our strategy now, let's say we're still doing our weekly full backups, our half-hourly log backups. Now let's add in a differential backup every day. Okay, so let's say at midnight every day we do a differential backup. So what happens if we crash on Saturday at 11:59 p.m.? What we're going to want to do is restore our most recent full backup, right, from the previous Saturday night, and then we're going to restore our most recent differential backup. Now our most recent differential backup is going to be Saturday morning, midnight. Right? So that differential backup Saturday morning midnight means we don't have to restore all of the log backups that happened on Sunday, Monday, Tuesday, Wednesday, Thursday, and Friday. Okay? So we're able to skip 6 days of log backups by restoring a differential backup. And then we have to restore all the log backups that happened on Saturday. Okay? So this is how the small bank story would have turned out better. If they'd been doing, say, weekly differential backups, they would have been able to restore their full backup from January 2004, their most recent differential backup from April 2004, and then maybe a week's worth of log backups. And they would have been up and running within, say, half a day or a day, and they might not have gone out of business because of that. So planning the restore strategy that you want to be able to do is often going to say you need to use differential backups as well. And for some reason, a lot of people don't like differential backups. They think they're complicated or scary or something, and they're not at all. It's just another kind of backup. Yes, it does add a little bit of complication to your restore strategy, right? But you should have practiced your restore strategy before it comes time to actually restore for real. Okay, I always say you don't want to be learning the restore syntax the very first time you're ever having to recover from a disaster. Okay. So a few myths around backups. Okay, there's lots and lots of myths around backups. Okay, so all of the things that I'm saying here are true statements. They're not myths, they're true statements. Okay. So full and differential backups always contain some transaction log. Okay. So just like I mentioned how full backups have to back up some of the log as well to make sure that you can restore and you get a transactionally consistent view of the database, the same thing happens for differential backups. They also contain some transactional log as well. Okay. You can't mess around with what log backups are going to do. There's no control that you have over how much transactional log is going to be included in a log backup. So if you haven't done a log backup for a long amount of time, the log backup is going to back up everything that was generated in the log since your previous log backup. Okay. Now there's brute force things you can do like switching to the simple recovery model and dropping all the log, but that breaks your backup, your log backup chain, and you don't want to be doing that. Okay. We're going to talk about some of the restores that you can do in a second, and there's a way that you can stop at a particular point in time. Okay. And the syntax is available on all backups. Okay. It's there, the stop at syntax is there for full and differential backups. It works, but it doesn't do anything. It's a syntactical nicety. And I'll explain why that's the case when we get there. Okay. And then we talked about the concurrent log backups and the log clearing. Now, if you're interested, there's a couple of blog post links there. Back in May, I think it was 2011, I did a SQL Server DBA Myth a Day blog post series, and I got a bit carried away towards the end. And towards the end, I did 30 backup myths on the 30th of May. So go ahead and read both of those blog posts. There's all kinds of things that you may think or you may have heard about backups and restores that are actually incorrect. Okay. Backup compression. I thought I had a little slide on this. Okay. Very, very cool thing to make use of. Lots of people make use of backup compression, a way of being able to reduce your backup size, and it's especially useful if you have to keep your backups around for quite a while. Okay. And it's going to be a lot faster as well. So a backup that is able to be compressed pretty well is going to be faster to take the backup. Okay, so if you have a performance issue because the extra I/O load while you're doing your backup, then the compressed backup is going to reduce the time that you have that performance hit, and also it's going to mean your restore goes faster as well, which is great for any kind of disaster recovery. So any quick questions on backups? Any more questions on backups? Let's take 3 questions, and then we'll carry on doing restore.
Okay, can you explain how buffer count and maximum transfer size can speed up your backups?
No, I can, but I'm not going to as part of this presentation because it's too much of an in-depth explanation and it's going to take too much time. What I would do is I would Google and look for the SQL Cat team has a very good article that talks about tuning backup throughput. Okay, which talks about buffer count, max transfer size, and stuff like that. And that is where I would go to look for that. Okay, we just don't have time to get into that, unfortunately.
Okay. Does a copy-only full backup break the T-log sequence?
No. A copy-only full backup has nothing to do with the transaction logs. A copy-only full backup only has to do with differential backups. So what a copy-only full backup does does a full backup. It does everything that a full backup would do, but it doesn't go ahead and zero out those differential bitmaps that a differential backup looks at. Okay.
The switching from full to bulk log model break log shipping.
No, you can switch backwards and forwards between full and bulk logged as many times as you like, and it has no impact whatsoever on log shipping or your log backup chain.
Okay, let's see.
One more, and then we'll move on.
Looking at the anatomy of the transaction log, it would appear that the likelihood of fragmentation within the transaction log would be more likely with large amounts of VLFs in the transaction log. Is that a fair statement? If so, are there any good ways to fine-tune the number of VLFs? Too few could be bad too, in my opinion.
So the number of VLFs can affect the amount of time it takes for backups and restores, and also the recovery portion of a restore sequence. So yes, and there's a way you can tune it. What I would do is the easiest thing to point you at is go to Google or Bing and look for Kimberly space 8 space steps. And both of those search engines, the first thing that will come up is a blog post from Kimberly that talks about how to make sure you've got the right number of VLFs.
Okay.
Okay. All right, so let's move on and do a few more slides. Thanks, Steve. Okay, phases of restore. I've got a few slides that talk about restores, and I'll do a couple of little demos, and then we'll take a whole bunch more questions. So phases of restore. When you restore a backup, the first thing it's going to do is check to see if it has to go and create the files, right, that it's going to be restoring. So if you're not overwriting a database that's already there, and in some cases that's not a thing you want to do anyway, right, it's going to go and create the files. And it's going to have to initialize the files if necessary. So you want to make sure you've got an option enabled on your system called instant file initialization, or instant initialization. If you've never heard of it before, go Google Bing it, and you'll see a bunch of blog posts that say how to turn it on. Okay, it basically allows the system, SQL Server, to not have to zero initialize data files. You absolutely want that enabled if you're doing any kind of disaster recovery, because say you're restoring a terabyte-sized database, you don't want to have to wait 3 or 4 hours while it goes ahead and zeroes out that data file just to then go and overwrite it. Okay. The instant file initialization is not going to affect the transaction log. So if you have a transaction log file that's being created as part of the restore, it will have to be zero initialized, and there's nothing you can do to stop that. The only thing you can do to speed that up is make sure you have the transaction log on a fast portion of your I/O subsystem. Okay, that's going to speed that up. So it's going to create the files if necessary, and then it's going to copy the data and or the transaction log, depending on what kind of backup it is that you're restoring. And then it's going to do the redo portion of recovery and then the undo portion of recovery. So very quickly, what the redo portion of recovery is doing is making sure that the changes from committed transactions are in the database. And it's called rolling forward transaction log. And it does the redo portion of recovery. If you have a restore sequence that is, for instance, restore a full backup, then restore a differential backup, then restore 10 log backups, it's going to do the redo portion of recovery for every single one of those restores as it goes along. And then right at the end, it's going to do the undo portion. And the undo portion of recovery you can think of as rolling back any changes from uncommitted transactions. Okay, so it obviously can only do that at the end of the restore sequence. That is the final step in any restore sequence. If at any point you allow the undo portion of recovery to run, that ends your restore sequence. So if you accidentally allow it to run, you're going to have to go back and restart your restore sequence. There's no way to undo that or just kind of roll it back a bit. You can't do that. Okay. So different things you can do to make your restores go faster. Instant file initialization, like I talked about. Backup compression, like I talked about. Okay. Backing up to multiple devices. Okay, so allowing the backup on restore system to make use of parallelism inside itself and in the I/O subsystem. The faster the I/O subsystem you've got, the faster the copies, the reads and the writes are going to do. Okay? And then if you have a very long-running transaction, right, you might unfortunately run into the case where right at the end of that long-running transaction is the point at which you're trying to restore to. And so it's going to have to roll back that long-running transaction into your database before your database comes online. So there's all kinds of different things you can do. And then, of course, there's more advanced things like messing around with buffer count, max transfer size, and stuff like that that we don't have time to get into today. that you can do to make your backups go faster and your restores go faster as well. So different kinds of restores. You can restore obviously a full backup and a differential backup in its entirety. You don't have any option to do that. With log backups, you do have an option. You can restore a log backup to a particular point in time. Okay, now there's all kinds of different options about restores. I'm not going to go into all of them, some more advanced than others, but I talk about all of them in my blog and in some of the reference articles I'll give you at the end of the deck. But there's a very simple one where you can say stop at a particular time. Okay. And I'm going to demonstrate this for you in a second. Now there's also, how would you like the backup to finish? Would you like it to run the undo portion of recovery and finish the restore sequence? And that's known as with recovery. And that, unfortunately, is the default. Okay? It's horrible. It's horrible because it catches people out. And if you don't say with no recovery, then it's going to do with recovery, and it's going to end your restore sequence. And if that's not what you want, you have to go back and start it again. Okay? So I always like to say, if your restore sequence has more than one backup in it, say with no recovery everywhere. Just make it your default on every one of your restore statements. Say with no recovery. Because then right at the end of your restore sequence, you can go and say, okay, now finish. And I'll show you how to do that in a second. Okay. There's also another cool thing you can do, which is with standby. And what with standby does is it allows you to kind of interrupt a restore sequence, get a read-only copy of the database to look at, or I should say read-only access to the database you're restoring, and then you can go poke around and see what's there and what's not there, and then you can carry on restoring more stuff afterwards. So let's have a little look at that. So recovery options. Very simple demo. What I'm going to do is I'm going to create a database, and as I said at the beginning, I'm going to create a zip file of these two demos that I'm going to do and give them to Steve so he can put it up on the PASS website. So I'm creating a very simple database, and I'm going to create a test table, and my test table just has a number and a character string. Again, it's a really contrived scenario just to show you what's going on here. So I create my contrived table, and then I'm going to create a transaction. So transaction number 1 goes in there. Okay. And then I'm going to take a full backup. So I've now got a full backup. Then I'm going to run another couple of transactions. And then take a log backup. And I'll show you a timeline in a second that describes what I've done. So I've got my first log backup. And another couple of transactions. Okay. And then I'm going to do a select get date. So that's going to give me a time that I can restore to. And wouldn't it be cool if before any disaster, where somebody dropped a table or something, everybody did a select get date so that they could tell you what time it was that they did that thing, and you could use that to restore to. But unfortunately, that's not how the world works. Okay. But in my little contrived demo, this is how the world works. So then another couple of transactions, another log backup, and then oops, database is gone. So here's my scenario here. This is a scenario that I've got in my demo. So I did my create database, transaction number 1, a full backup, transactions 2 and 3, a log backup, transactions 4 and 5, I selected the date, transactions 6 and 7, and my second log backup. Okay. So let's play around with what we can do with our restores here. So first off, let's just restore everything. So I restore my database backup, I restore my 2 log backups. And I get an error. It says, no, you can't. Okay. And basically what this error is saying is, you already finished the restore sequence with the full backup. You can't restore these log backups. If I look back on what I did, oops, I forgot to say with no recovery here. So this finished the restore sequence. So there was no active restore for me to restore this on top of, or roll forward, if you will. So I have to go back and start again. So now I restore my database. I'm replacing what was there before, and I say with no recovery. And that's going to allow me to go ahead and restore another backup in my restore sequence. So now I can restore my first log backup with recovery, allowing me to restore my second backup. And I'm saying with no recovery as well. Okay. Now at this point I can't get into the database because it's still in the restoring state. So I have to tell the restore system, hey, we're done. And the way that I do that is with this statement. whatever restore operation is going on the company database, run undo. That's all that says. Notice that I'm not specifying a backup. I'm just telling the restore system, we're done. Go run the undo system. Even if there's nothing to do, like it says there was nothing for it to do, you still have to run this statement, okay, if you've done with no recovery on every one of your backups, or restores, I should say. So, did everything get restored? Yes, there's all my transactions. Okay. So now let's say we want to examine what's happening in between each of the restores. So I'm going to use with standby, and these options are all mutually exclusive. You can't say with no recovery and with standby. So the way that you use with standby is you give a little file name here, and it actually goes ahead and does the undo, but it does it into this little file here rather than into the log file itself. Okay, so it doesn't actually go and change the log file, and that allows the system to go and replay things as if you were doing with no recovery. Okay, so what standby actually does is with no recovery, but let me look and see what's there. Okay, you can think of it as that. So if I did with standby for our full backup, going back to my timeline, that was at this time here, so I should only see transaction 1 in my table. Like so. Now just to prove that I can't do anything, let's try changing that database. And it says no, it's read-only. Okay, so standby gives you a read-only view of that database. So let's do the next log file. So if I restore something else in my restore sequence, what it goes and does is it looks inside here and it goes and undoes everything it did there. Okay, so it puts the database back into as if we just did no recovery. And then it allows us to carry on restoring. So if I restore this log backup and then say with standby as well, that's going to take us to this point in time here. So I'm going to see transactions 1, 2, and 3. Like so. Then I go ahead and finish off restoring everything. Okay? And then I'll see all my transactions are there. So you can interrupt your restore sequence using with standby as many times as you want, and it's not going to cause you any problems. So now let's say that I don't like transactions 6 and 7. So I want to stop at the time just before transaction 6, and I just happen to have that time stored. Okay? So what I can do is say with stop at, and I can plug that time in there. Okay? Now just like if you have more than one backup in your restore sequence, it's the best practice to use with no recovery, right? Just to make sure you don't accidentally do with recovery. If you're doing a point in time restore, put with stop at on every single one of your restore statements, to make sure you don't accidentally go past that point in time. Because if you accidentally go past that point in time, there's no going back. You have to restart your restore sequence. And this is why the syntax allows you to say with stop at, even on a full or a differential backup. You can't stop in the middle of a full or differential backup, but the syntax allows it to be there so that you can do that best practice. So we go ahead and do that. That works. And we go ahead and do the with stop at on our first log backup. Okay, and we say with standby. And it's actually smart enough to say, look, the time that you specified, okay, it's actually not contained within this log backup. You need to go forward. Okay, so let's say that we don't trust SQL Server, and we're going to go and look and say, are we at the right point in time yet? Because I did it with standby as well. No, we're not at the time between points 5 and 6. So we go ahead and restore the second log backup. Okay, so what we're doing here is we're saying restore, we've already restored full, we've restored log 1, and now we're saying restore log 2, but don't go any further than this point here. Like so. Now if we look and see where we are, we're at our right point in time. We actually stopped in the middle of the time period covered by log backup number 2. And we can say, okay, we're done. That's where we want to restore to. So I'm going to allow the restore sequence to finish, and then make sure we're still at the right point in time. Yes, perfect. But what I'm going to do now is I'm going to take another backup. I'm going to take another full backup. And what that's done, going back to my slides, that's the end of my demo, so go back to my slides here. What that's done when I did my full backup is I took a full backup here. Right? So now we've taken this database down a different timeline. And the reason I took my full backup here was because if I then, so let's say we do another log backup here and another log backup here, and we crash, okay? If I don't have this full backup, then to get back to this point in time here, I have to go back and do full backup restore, log 1 restore, log 2 restore with stop at, and then this log backup and this log backup to get back up to this point in time. And to short circuit having to do that, I start a new restore sequence by taking this full backup here to avoid having to do all this earlier disaster recovery. So let's move on. So I won't take any more questions now until the end of the session. I don't have very much more to go, maybe another 5 or 10 minutes, and then we'll stay and do whatever questions people have. So we've looked at restoring the entire database. There are things you can do which restore just a portion of a database, and we don't have time to go into all these today. So for instance, you could restore what's called a partial restore that says, I'm restoring from scratch, but I'm not restoring all of the file groups in my database, just some of them. Then I'm going to bring the database online and be able to restore some of the other file groups after that point in time. There's things you can do called piecemeal restores, where you can say, I just want to restore one page in a database, or one file in a database, or one file group in a database. Okay? And in an enterprise edition, you can do those online, right, while there's activity in the rest of the database. Okay? Again, beyond the scope of this, but I do cover some of those in the Pluralsight courses and also in the articles I'm going to point you at. Now, whatever you're doing, everything that you're restoring has to be brought up to the same point in time as the rest of the database. Okay, so basically the same point in time as the primary file group. Okay, you can't have a read-write file group that's restored to a different point in time from the rest of the database. Okay. Also, you can't take a file group from one database and another file group from another database and try and restore them into the same database. That doesn't work. There's no mixing and matching of file groups. Okay, so SQL Server doesn't have the notion of transportable table spaces that Oracle does. So with our various different backups that we have now, that we've talked about, let's say that we have a disaster at time X. Okay. The very first thing that we might want to do is back up what's called the tail of the log, and I'll do a little demo of that in a second. This is backing up everything since the most recent log backup, if you're able to. Okay, so it's kind of a final log backup that you're going to do, right? Because a restore sequence to restore right up to the point of the crash is going to have to include all the log that was generated between the most recent log backup and the point of the crash. So let's see, our restore sequence is going to be starting with our full backup, whatever the most recent differential backup is, and you can see how it skips all of those earlier log backups because it is the net effect of all of those log backups. And then whatever log backups are necessary, plus that special tail of the log backup to bring us up right to the point in time of the crash. Okay. How long do you keep backups around? Right. You have to assume that some of your backups might go bad. So for instance, if you've just taken a full backup, that doesn't mean you go and delete the previous one. Because what happens if you have a disaster and you go to restore that only full backup you have now and it's damaged? Game over. Okay. You need to be able to have a fallback position. So you need to keep the previous full backup so that you can go back and restore from the previous full backup if your most recent full backup is damaged. And that also means that you're going to have to keep older differential and log backups around. So how long do you keep them around? Okay. There's no right answer to this. If you pushed me, I might say, well, let's say we are doing the weekly full, daily diff, and half-hourly log backups. I might say keep around 3 months worth of full backups. Okay, that means you're probably keeping around 3 months worth of differentials and log backups as well. Okay, it's like security, defense in depth. You want to make sure that if a secondary disaster occurs, so you've had data loss and now you find that your backups are corrupt as well, you can go back to earlier backups. Okay, because if you don't have any earlier backups, it could be complete data loss, game over, and your company goes out of business. Okay, and there have been various stories of that happening to companies. So let's say that we have a disaster and we find that our most recent differential backup is bad. Well, that means we can fall back on the previous differential backup and all of those log backups, right, to get us up to the right point in time. So you want to have different strategies available to you, right? And you do that by keeping your backups around. So let's have a little look at a tail of the log backup. And the title of the log backup, as I said, is backing up that final portion of the transaction log after a disaster occurs. So I'm going to go ahead and recreate my little company database. Again, very simple scenario. Create my test table, insert a transaction. Oops. Create test table, insert my transaction. Full backup. A couple more transactions. And then, unfortunately, before we can do a log backup, a disaster occurs. So I'm simulating a disaster. So a disaster occurs, and unfortunately, the data file is destroyed, like so. The database comes back online, or SQL Server recovers, and we start getting all kinds of errors. So the database is inaccessible. We're missing data files. So we're going to have to do a restore. So the first thing that we might check for in our disaster recovery handbook is, do we need to do a tail of the log backup? And a tail of the log backup is we back up the log. In other words, back up all the log since the last log backup. But if the data files aren't there, it's not going to allow you to do that. So there's some syntax you can use called no truncate, which says even if the data files aren't there, allow me to back up the tail of the log. And that backs up the tail of the log. So this is called a tail log or tail of the log backup. And that tail of the log backup can now be used in my restore sequence. Now this is a contrived example, obviously. In a real-life situation, you might have a whole bunch of different restores you can do, you have to do, and then right at the end of the restore sequence, you have your log backup, your tail of the log backup. So just to make my demo quicker, I'm just doing my full backup restore with no recovery, and then my tail of the log backup, I'm just allowing it to run recovery. I didn't say with no recovery here. And then by backing up the tail of the log, I was able to get transactions 2 and 3 that hadn't previously been backed up. Even though the data file was destroyed, I was still able to salvage those 2 transactions. So a very simple example of a tail of the log backup. And I talk about them more in the Pluralsight course. And I've got a demo, I've got several demos on my blog as well that talk about using tail of the log backups. So we're almost done. So your strategy, and now, as I said, we only had a bit of time today, and I haven't been able to cover absolutely everything about backup strategies. There's all kinds of depth to it. But you should have enough information now to be able to understand, first of all, how to figure out roughly what your strategy needs to be based on what restores you want to be able to do. You now understand what full backups are and how they work, differential backups are and how they work, and what log backups are and how they work, and how a differential backup can be used to be able to short-circuit having to restore a whole bunch of log backups. We talked a little bit about backup compression and how that can save you space and restore time, and also backup time as well. We didn't talk about things called backup checksums. Everybody should use with checksum on their backups as well. And we haven't had time to talk about verifying your backups, but that again is something that everybody should do. So just because you're taking backups doesn't mean that they're valid. You need to be testing your backup strategy, which means you go ahead and you do test restore sequences on another server that make sure that your backups are correct. Now, several times I mentioned a disaster recovery runbook or guide. That says that you need to have thought in advance about if a disaster occurs, what are you going to do? And you also want to write that down. So if you're not there, if you're on vacation, somebody else can follow that disaster recovery plan and at least have a good chance of being able to run a restore sequence and get your system back up and running. But at the very, very least, have some kind of strategy. Make sure you're taking backups, at least. Make sure you're testing them. And have at least tested them once to make sure that what you're doing with your backups is allowing you to do the restores that you want to be able to do. So here's a bunch more information. So there's an article that I wrote back in 2009. My goodness, that's a long time ago. So 6 years ago, but it's still completely, all of this stuff is completely relevant and it hardly changed at all today. Understanding SQL Server backups, recovering from disasters using backups. Those are 2 TechNet magazines. There's an article on more advanced backup and restore options a couple of years later in 2011. And then on these 2 blog post categories, huge amount of information about SLAs, using backups, using restores, and then in my main blog category, all kinds of more advanced information as well about various disaster recovery strategies and things you can do with backups and restores. So we are at 25 past 10 here in Pacific time zone, 25 past 12 Central time zone, and I'm happy to hang around for whatever questions you guys have. If you have to drop off now, thank you very much for watching. This is all going to be recorded. If you have any questions, feel free to send me an email, paul@SQLskills. It's on that slide that talks about me. And have a good day. But if you're going to hang around, let's do some questions.
Okay. Let's see. Can we check for corruption every day instead of keeping 3 months of backups as suggested to ensure we know almost immediately when corruption occurs?
This is an interesting question because yes, you could check for corruption every day, and you should be running checkDBs regularly. But what you're looking at is also, are your backups still valid? Because the I/O subsystem is what I like to call an equal opportunity corruptor. It'll corrupt anything. So, and just because you checked and your backups weren't corrupt, say today, doesn't mean that overnight something doesn't go wrong and they're corrupt tomorrow. So I wouldn't advise checking for corruption and using that as a mechanism for not being able to keep so many backups around. Okay, there's a very big possibility that you'll run into problems there. I would figure out the maximum amount of backups that you can keep around in terms of space, and always keep that amount around if you can. Okay,
the backup with verify, inside of the backup, a vendor had told this particular person it would save a lot of time to leave that off, but the person didn't trust the vendor. What exactly does that do? How secure should that make you?
Okay, so the option is with verify only. So in the Management Studio GUI, it says, verify the backup after it's taken. What that does is it's going to go ahead and run a restore with verify only. And a restore with verify only, there's two different ways it can run, depending on whether you also specified backup checksums or not. If you did not specify backup checksums, then all restore with verify only does is it looks at the very small backup header and says, does this look like a backup file? So it doesn't actually look at the backup at all. Okay? If you use backup checksums, then restore verify only will do two things. It will read through the entire backup, looking at all the data file pages in the database in the backup. It'll make sure that their page checksums are still valid, and it will also recalculate the checksum over the entire backup file and check that it is the same as the one that's stamped in the backup file header. Okay? So what the vendor was saying is kind of true. It might save a little bit of time, but I would never, ever, ever, ever turn it off. Okay? You always would want to have backup verification turned on if you're doing it through the UI, because again, defense in depth. If your backup failed, right, because it was written out to disk and then it was corrupt as soon as it's written out to disk because there's something wrong with that portion of the I/O subsystem, I'd want to know right away. So I would never turn that off. That's poor advice from that vendor there.
Does a restore retain DMV counters and execution plans or reset flush?
No. So what a backup is doing is purely a physical copy of what's in the data file and any log that's required as well. It does not copy or persist anything that is held in SQL Server's memory, which are the DMVs, the plan cache, and so on.
When I do an index rebuild on large databases, the log file blows up, even in bulk insert mode. How can this be avoided?
If you do an index rebuild, that is a single transaction, and so it's going to have to be entirely held within the transaction log. Now, even if you're doing in the bulk log recovery model and you're doing your index rebuild, if it's a particularly large index, then all the log records for all the pages could still cause your log to blow up. So the way that you can avoid having the log blow up by doing index rebuilds is not to do index rebuilds, but instead to do what's called an index reorganize, alter index reorganize. And alter index reorganize is based on the old DBCC index defrag that I wrote for SQL Server 2000. And that is a very different algorithm for addressing fragmentation issues without doing a build an entire new copy of the index. Now, talking about the differences there is beyond the scope of this session. Where would you go to look about that? Okay, so back on the slides. Oops. Down here, there's this Help Accidental DBA. This is a series of blog posts that we did a couple of years ago in June 2013, where it's all aimed at fundamentals for DBAs. And one of the bits of information in there talks about addressing index maintenance and talks about index reorganize versus index rebuilds. So go and have a look at that link there. And in fact, I can bring that up because I think I've got it on, I do have it here. So if we look at this link, Accidental DBA, it's going to show us all of the areas, also all the blog posts that talk about accidental DBA stuff or junior DBA stuff or DBA fundamentals. And this one here, index maintenance, is going to talk about rebuilds versus reorganize and some of the different things you can do there. So that's where I go look for that.
Okay, this one might be in some of the links, but this person is asking if you have any sample disaster run books that they can go look at, or you know of.
We don't have a sample one that we publish. If you go Google or Bing, you'll come up with some examples that people have put in. The reason that I don't have a sample one is because I don't want to have something published out there that maybe misses something that then somebody runs into trouble about. I'd rather that people would create their own ones. Right? But you can find examples out there.
Okay. I'm not sure I understand. Can I do a point in time in bulk log recovery mode?
So I think the question's asking, if I've done a minimally logged operation and then a log backup occurs, the log backup's going to contain a minimally logged operation. Can I do a point-in-time restore to a point-in-time covered by that log backup? And the answer is no. The log backup that contains that minimally logged operation can be used as part of a longer restore sequence. You can restore to any time before that, the period covered by that log backup. You can restore that log backup in its entirety or to any point afterwards. You can't stop at any point covered by that log backup because it contains a minimally logged operation.
This one's early on something I may have missed, so it may have already been answered. If you've done a copy-only full backup, would you be able to carry on with the log2 transaction log restore?
Yeah, we talked about that earlier on. So copy-only full backups have no effect. In fact, full backups themselves have absolutely no effect on log backups. The only thing that affects log backups are log backups. A copy-only full backup only affects the differential backups and which full backup you have to restore before you can make use of a particular differential backup.
Okay, this one I'm not sure about either. I noticed that the size of my nightly full backup files are always the same size, 19K, no matter how small or how large data updates are happening from users on a daily basis. So is there a percentage limit set somewhere perhaps?
Did you say the full backup was the same size?
That's what they're saying. It sounds like they're not getting a backup. Yes, he said yes.
If the full backup's always the same size, that would say that there's no new pages being allocated inside the database. If you're inserting a lot of data and you're not seeing the size of the backup go up, the only thing I can think of is it may be that your tables are a heap and there's a lot of free space that's in those tables for maybe an earlier delete operation on a previous version of SQL Server that didn't deallocate all those empty pages, and it's going through and using those pages. But in general, if you're doing inserts and you're seeing data growth, you should see the size of your full backups increasing.
Okay.
So whoever asked that, if you're still there and listening, and you want more clarification, shoot me an email. I can look and see what's going on.
Okay. I've heard the term breaking the backup. What does doing a full backup manually break the backup? How can you tell if your backup is in fact broken? Only by testing your restore.
So I think what the person's heard is about breaking the log backup chain. Okay. So breaking the log backup chain is nothing that you can do from taking full backups. The thing that's going to break the log backup chain is switching to, for instance, the simple recovery mode. If you switch to the simple recovery mode, that breaks the log backup chain, and you have to restart the log backup chain by either taking a full or a differential backup. In other words, bridge the gap in the log that will have been thrown away by going to the simple recovery mode.
Okay, this is an end of session question. Describe a good marriage between a third-party backup tool like Barracuda and the native SQL backup tools. Thanks.
Can you repeat the question? I didn't hear the first part.
Describe a good marriage between a third-party backup tool like Barracuda and the native SQL backup tools. Thanks.
This is an interesting question because what I find is unless the third-party tool is using SQL native backups, right? So, for instance, SQL service backups themselves, or something like Redgate or something like that. I found that general system backup services don't do a good job of SQL Server. Okay. Now, I'm not going to name any backup providers, but I've seen plenty of cases where non-SQL Server specific third-party tools either have failed to be able to restore SQL Server backups, or have had problems with SQL Server databases after the backups have been restored, maybe not to the right point in time or something like that. So I personally do not trust any tool that is not SQL Server specific. And again, that is something like SQL Server backups themselves, or a SQL Server third party, for instance, Redgate, and they're the one that comes most to mind.
Okay. Is it possible to restore without a log file? Let's say the log file is corrupted.
So interesting, because does the questioner mean the log file is corrupt once it's been restored? Because you can't restore without a log file. Any restore you do is going to create a log file. Or do they mean, can they recover if the log file is corrupted?
I'm guessing that, okay, they're still here. They're still signed down if they want to ask. I think they're probably meaning, can they recover if the log file is corrupted?
So if they're still logged in, can whoever asked clarify that question?
Yes.
And if they can't, send it to me in email, and we can go back and forwards and figure out exactly what you mean.
Okay. Let's see. How does SQL Server recover from a failure when a committed data was in the log buffer and did not write into the log file before failure?
So if you have a transaction that's running and the transaction hasn't yet committed, then if a system crash occurs, that transaction will roll back. Okay, there is absolutely no way to work around that, because unless there's a commit log record for that transaction in the log, when the system recovers, that that transaction will roll back. Let's say that you are in the process of doing a commit. So the commit log record had been generated, but the log buffer was in the process of being flushed to disk, but the system crashed before that log buffer could be written to disk. Same thing. Okay, if the log record is not on disk when crash recovery runs, the transaction gets rolled back.
Okay, and it's looking like we may. Okay, here's another TDD encryption. If you were previously using compression, will the backup size increase if you go to using transparent data encryption?
So the answer is it depends, and the answer depends on whether you were able to get any compression ratio before you enable TDE. So if your compression ratio before TDE was 0 and you enable TDE, then there'll be no change in the size of your backup. If you were able to get some compression before you enable TDE and then you enable TDE, you will go to 0% compression, and so your backup size will increase. So although I said it depends, the answer is probably yes, your backup size is going to increase.
I think that's it.
Okay.
This session generated a ton of questions.
Cool.
Okay. Really appreciate it. It has been a great session. Thanks for everybody for sticking around in YouTube call. We hope to have you back sometime in the future because it's great. Anyway, the winner of the $25 gift card, Amazon gift card, is Brian Hibbert. That we'll be getting back to you a little bit later. And be sure and sign up for our session next month with Wayne Chavez with getting started with SQL Azure databases. Thank you.
Thanks, Steve. Thanks, everybody.